Hello, welcome back to my YouTube channel. And today I will make a video on section 6.1, which is homework about like area between the curves. And from now on, we are take a brief pause on integration technique, and we will learn some basic applications of integration, which is the area and the volume. And my intent of making this video it is just to save your time doing the homework, because I know some of them you're take a full course loads like 2 or 3 week of classes and they're time consuming. And I wanted just to save your time because I know time's precious, that you're precious too. I want to make life easier, so this is my purpose of making this. Okay, let's get started. So area between curves, so whenever you see a question, there now in this section we're talking about the area between two curves. It's not between one curve. Area under one curve, it is just a definite integral. And now we are finding the area bounded by two curves. And to make area positive, we had to make sure that it's just the top curve minus the bottom curve. And how do you, and the most complicated part of this part, it is how do you just set up integral. So all the function, all the two curves here, they're in terms of x, and is top-down layout. The half interval is from the origin to this point. In this case, two functions are already available, and they have this intersection. You just use like dx as the integration variables, and the top minus bottom dx also is like interval. Make sure it is x values from x equal to 0 to 7. That is your interval, upper bound and lower bound. Number two, there's no visual representation here. So your first step is to find the intersection point. You have y equal to 4 over x and y to 8 over x squared. X equal to 6 is the upper bound. You need to find their intersection point. If x it is larger than 6, then 6 is the lower bound of the integral. If the 6 is higher than the another intersection, then 6 is upper bound. And the behavior function is in the first quadrant. And in the third quadrant, it's going to be negative. It's like x equal to 6. This means the area bounded is in the first quadrant. Why? Because x equal to 6 axis is not from the third quadrant. So we eliminate. There's nothing to eliminate, but just to plugging the value to find the intersection. And behavior is increasing, so this one, they're out. Now between this one and this one. And they're rational functions. And so the denominator cannot be a 0. The function will be undefined. So this one is out. I didn't find how to determine there's like which curve is above. and which curve is under. Just plug any integers over this interval to both functions. The function with the higher output is on the top, lower one is on the bottom. This is if we have the layouts like right left positionality, we use dy to integrate. X of dy is an increasing function. So we eliminate this one out because it's decreasing. And this one is also, this is decreasing. So also those ones, they're false. If you see x equal to a 0, y is 0. If you plug in x equal to a 0, y is square root of 48. It's going to be something between 6 and 8, just to try to compute the intersection here. And we determine this graph. We have a left and right positionality. Use dy to integrate. Then 8 can be the upper bound, and the -6 is the lower bound. If it's in dy to integrate, then this right curve minus the left curve. It's the same thing as using dy to integrate. Left-right positionality. So this one and this one, they're out. So the rule of thumb of like everything curves like right-left positionality using dy. Top-bottom positionality using dx. Using calculus to find the area triangle here. So just draw the point on the graph, and then you will find the triangle here. Just there might be a function of how much decreasing and increasing. So here, so you need just to split up the region, then just find the linear equation between 3 points, and then use L'Hopital curve to find the total area. In this case, you need to do L'Hopital curve 2 times in a row, but different functions. There are 6 here is like you need to find this curve and the intersection. N equal to 4, midpoint is going to be n equal to 1/8, 3/8, 5/8, 7/8. Those are like the point to put. You just have the integrals available and to find the positionality, and then you just need to you don't need to evaluate the integral because like we cannot evaluate this with our current integration method. So this method, so this integral, is not solvable until now. But if it's solved later in the quarter. I narrowed it down. I would make, I think number 8 is like you just bisect. It means like if you have a region, there's a 2 line here. It means like just equally divided region. So if here's the region, point A, it just be bisect. This part is equal to this part. So what you need to do is you have the integral to compute the total area of the region is integral of 1 to 4 over 1 over x to the squared. Find this area, then set antiderivative is, and then set the then set the function is like going to be a over 1, and just do like the thing. I would make a handwritten guide here later because I need to make some visual representations here. Because no, this is going to be the hardest question in this homework. So don't worry, I'm gonna make a homework guide for this problem because I know it is hard. Thanks so much for thank you so much for watching and have a wonderful day.
I think it's easy, but like a lot of
In
questions
next
like really tricky. You gotta put like
in next
gotta put some time in it and like
in the next fifth
have to analyze each word.
video, I'm gonna talking about the volume by
The format is
slicing and for sectional areas, which will be more challenging and more fun. And
not general.
thank you guys for
It's just
watching
like
again.
coming up with a final solution, like addition.